Hi everyone, welcome to the session today. I know it was a tough choice. There is the welcome reception, but I promise we'll make it worth your while. In this session, we are going to dive into some powerful strategies to help you reduce cost and improve efficiencies for log analytics and search workloads using Amazon OpenSearch service. I am Hajar Bouafif. I work as a senior OpenSearch solutions architect at AWS, helping customers on their daily work to improve their OpenSearch workloads for search and log analytics. With me today, Kevin Fallis. Kevin, would you like to introduce yourself?
Hi, my name is Kevin Fallis. I'm a principal. I work with the Amazon OpenSearch service, a worldwide sales organization, helping customers such as yourself understand, of all things, cost optimization with the Amazon OpenSearch service.
And with us, Pavan Chaturi from Trellix. Pavan.
Hey everyone, I'm Pavan from Trellix. I work as a senior software engineering manager there. I handle Trellix XDR product operations, SRE operations.
All right.
Nice to meet you all.
Thank you Pavan and Kevin. So let me start with introducing what is OpenSearch, the open source platform that is powering Amazon OpenSearch service. So OpenSearch is an open source platform, Apache 2.0 licensed. It has been recently part of the Linux Foundation, reinforcing its vision to the open source community. We have customers using OpenSearch with over 750 million downloads. We have been ranked, or OpenSearch have been ranked in the top 4 search engines within the DB Engine website. And we have a growing number of partners, like over 80 partners participating, contributing to the project with hundreds of weekly contributions. And of course, you can deploy OpenSearch in different providers, AWS, Oracle, Azure, etc. Now, AWS offers a managed version of OpenSearch open source, which is Amazon OpenSearch service. So with OpenSearch service, you get the full capabilities of OpenSearch open source combined with the scalability, security, and availability of AWS Cloud. AWS offers also a third version of OpenSearch deployment, which is Amazon OpenSearch Serverless. With OpenSearch Serverless, you don't need to provision any instances, and it requires very minimum knowledge into OpenSearch internals, like sharding best practices, indexing best practices, etc. Now, when building your search or log analytics workloads, you need to think about your overall total cost of ownership, or TCO. Think about TCO as a shared responsibility, where AWS takes care of aspects like scalability, availability, also making the service compliance ready and secure. While yourself, you would need to focus on some key elements, such as compute requirements, storage requirements. You should also think about the usage patterns, meaning who are the users that are querying the data? How many users do you have? What's the frequency of search? And also consider the type of search queries that they are running. So if you have heavy aggregations, for example, that will drive your compute requirements up. Also think about the operational simplicity with the different deployment options that we covered with the self-managed, managed service, and OpenSearch serverless. Myself and Kevin will dive into the strategies, how to improve these key factors to help optimize the cost and efficiencies. Now, OpenSearch is a search engine, and in search use cases in particular, it goes beyond text search into providing vector search capabilities. This will help you better understand your user intention on your application, right? And this powers use cases like retrieval augmented generation use cases, or RAG, e-commerce website search, document search, etc. Let's dive into the vector workloads in particular and see how we can optimize the cost for this type of workloads. Now, when we talk about vector search, we talk about k-nearest neighbor search, or short for KNN search. So I am gonna go with a quick check of room, like who still did not hear about KNN search yet, with a raise of hand. Few of you, all right. At the core of vector search, there's the concept of representing data in high numeric dimensional vector. In this space of vectors, the data, we try to represent the data in these vectors, and the data with similar characteristics, whether text or images or audio, are represented in close to each other in that same vector space. And when we have a query or user query vector, KNN search, as the name entails, it will find the k nearest neighbors in that same vector space. Now, the search operation can be exact or can be approximate. With the exact KNN search will try to compare the input query vector to every vector in your index. This can lead to pretty good accuracy. However, it can also lead to higher search speed, especially if you have large workloads like billions of vectors. This is where the approximate KNN comes into the picture. Approximate KNN uses algorithms like IVF, HNSW. These algorithms allow us to quickly find the key nearest neighbors to our input query vector, while compromising the accuracy, like slightly compromising the accuracy, I would say. Now, to provide this good speed of search, we need to make sure that the KNN index or your vector data are loaded into memory. This is why your vector workloads are, or the cost of vector workloads are mainly driven by memory, actually. To reduce the memory requirements or your memory footprint in your vector workloads and thus reduce the overall cost, think about using techniques that we call vector quantization techniques. With OpenSearch, you can use color quantization, binary quantization, and product quantization. These techniques, think about them as compression techniques that will reduce the vector dimension from 32-bit down to 16-bit, 8, or even like one binary, like 1 bit. Also consider above the quantization techniques, making sure that you have the right dimension numbers of your vectors. If you have thousands of dimensions, that will also increase your memory footprint requirements. Then I would recommend you to think about metrics to measure the efficiency of your vector workloads, like accuracy of results, also the speed of search, but also consider the index speed. Meaning, if you need to quickly index the data and make it available for search, you need to measure how long does it take to index these data into the graphs, for example, with HNSW approximate KNN. Also think about if you have frequent updates, how to manage that aspect and the speed of updates, and of course measure the memory, compute, and storage requirements. Now, with this overview of the different techniques and the optimizations that I shared with the quantization, I would like to share this graph that gives you kind of high-level understanding of how the overall cost will look like for vector workloads in particular. If we take the exact KNN, this is what we mentioned, like it's very compute heavy if once your data increases or gets larger, basically. And then to optimize that, we move from exact KNN into approximate KNN. You can also further reduce cost with the quantization techniques that we have covered. However, this quantization techniques comes with the trade-off of accuracy and latency. On the accuracy side, the scalar quantization and disk optimized with binary quantization gives a pretty consistent accuracy. However, with the product quantization technique, it's more variable accuracy. You can still overcome this by training your product quantizer model, though. On the speed of search, so exact canal leads to higher search latencies, especially once you're on a billion scale of vectors. And then the disk optimized with binary quantization, it involves some disk-based search. So you kind of expect also high latency compared to when all your vectors are loaded into memory, but we're still in millisecond scale here. So it's like we're still less than 300 milliseconds. So this is pretty efficient actually for RAG use cases, document search, internal document search. Also, if you have research and development teams, they are experimenting with different techniques for your generative AI application. Think about also binary quantization with disk optimized. Now, the approximate canon and scalar quantization in particular provides you with the best trade-off of speed of search, accuracy, and also overall cost. And from this slide, what I would like to leave you with is that every approach has its own benefit, so you need to kind of measure what it will bring as benefits for your own use cases. Now that we have explored how to optimize the vector workloads, you can use the Amazon OpenSearch Managed offering or OpenSearch Serverless. Let's dive into OpenSearch Serverless approach here. So the serverless architecture of OpenSearch decouples the compute from the storage layer, where the storage is based on Amazon S3, the highly scalable storage tier. This separation of concerns allow us to scale the indexing and search independently, basically, optimizing the resource utilization within the service. OpenSearch Serverless offers 3 types of collections. The time series collection optimized for log analytics. It has built-in storage sharing, meaning we keep the most recent data into the OCUs or the compute layer and the old data into Amazon S3. The search collection is optimized for text search based, and it has built-in shard replica scaling, meaning like in search of spike of search, instead of adding more compute into it, we just scale the number of replica shard to handle those spikes. And the vector search collection is optimized for your vector search workloads, of course. And if you are using the knowledge base within Amazon Bedrock will automatically create an OpenSearch serverless index for you. Now, by offering these specialized collection types, we make sure that the underlying infrastructure and sharding strategies, indexing strategies are optimized for your workloads and generally. Like giving back time to your team actually to focus on business side of things instead of focusing on tuning the infrastructure. Also, OpenSearch Serverless will automatically scale up and down to handle your workload spikes, and it can scale up to 500 OCUs for your indexing and for search, so it's important to set the maximum of OCUs per account. And of course, you can also reduce further the cost by sharing the OCUs or the compute unit between different collections. Now, one of the most common challenges that customers face when building search or log analytics workloads is how can I make the data available into OpenSearch quickly, basically. Now, if you are relying on licensed toolings, that can limit your solution growth. It can also limit the architecture design, basically, in terms of integrations with other tools in your environments. Then if you are self-managing your data pipeline, that can also increase like the operational overhead for your team and deterring your team from building the business instead of handling the infrastructure scaling and overall cost. To remove the heavy lifting, Amazon or AWS introduced Amazon OpenSearch ingestion service. It is a fully managed pay-as-you-go data ingestion service that is powered by DataPrepper. DataPrepper is an open source data collector. It is part of OpenSearch project, OpenSearch open source project. And the service delivers a secure and reliable ingestion pipeline through multi-visibility zone deployments, and it integrates with most of the popular sources like Kafka, OpenTelemetry, S3, and even other databases. It also has out-of-the-box transformations to filter the data, transform the data, and ingest the data into the downstream application like Amazon OpenSearch or Amazon S3. Now, to help you get up and running with the ingestion pipelines, OpenSearch Ingestion Service offers up to 38 blueprints that you can see part of them on the screen. These blueprints, think about them as templates that will allow you to quickly start with the ingestion pipelines. You just need to fix or rename the index name, what is the IAM roles to help you read from the source and index into your downstream services. Now, with OpenSearch Ingestion Service, you will give back time to your engineering. So this aspect of helping your team to focus on the business is pretty existent here, or pretty recurrent. And it is based on DataPrepper, so there is no additional fee to pay. And OpenSearch Ingestion Service automatically scales to handle your workload demand. And it also accelerates the integration with other services like DynamoDB. So we have this zero ETL with DynamoDB. We have zero ETL with S3 that Kevin will share later. And of course, other services and announcements you will hear through reInvent this week. Now, while serverless options that we have covered bring simplicities in your operations, there are also ways how you can further optimize the cost with Amazon OpenSearch Managed offering. And this is where I would like to introduce Amazon OpenSearch OR1 Instances. So when running OpenSearch, we typically recommend having at least one replica of your data to make sure that you have a reliable and available solution. So traditionally, this will involve indexing the data into both the primary and the replica shard, leading into redundant compute on your cluster. With the introduction of OR1 instances, there is a better approach to the replication process. This process, I would say, it's called segment replication with remote storage. It may sound complex, but actually it's how serverless also operates. So here's how it works. First, we'll index the data into the primary shard only, in the yellow color. And the new segments will be persistent into Amazon S3. And then instead of re-indexing the data into the replica shard, the second data node here will just fetch the new indexed data from S3. It will read from S3 and copy the data into the replica. This improves indexing throughput by 80%. It will lead to 30% price performance improvements because now we have more compute available in the cluster to handle other tasks than re-indexing into the replica. And also, you may not need replicas because you already benefit from the 11 nines of durability of Amazon S3. And last but not least, OR1 instances keep a copy of the data in Amazon S3, but also persist the cluster configuration, like index templates or index mapping. So in case of a failure, it will recover not only the data, but also the cluster configuration. This will improve the resiliency and recovery time. Now, Kevin will share more on the cost optimizations approaches and technique with Amazon OpenSearch Service and how to build efficient ingestion workloads with Amazon OpenSearch Ingestion Service. Before that, let's hear from Pavan how Trellix achieved over 35% of cost improvement with OpenSearch service. Over to you, Pavan.
Yeah, thank you, Hazar. Hey everyone, good evening. I'm from Trellix, and our company operates in cybersecurity domain. We have an AI-powered open platform with many security integration, security controls integration. We are trusted by many global Fortune 100 companies, and we have, you could see, we are kind of top innovator, and we have received many achievements. So our use case is mainly around security needs a platform, and then how we use OpenSearch at the backend to power this platform. This will emphasize why security needs a platform, right? You could see here there are many security controls like endpoint security, network security, email security, data protection, cloud, third party, and it will be operating in many environments like cloud, on-prem, hybrid. So to consolidate all these events and then add Intel to it and then make them actionable alerts, we need something on the top with a console which will provide dashboarding, case management, policy, threat hunting, all those options at the top. So to provide all these things, we need something at the back where we could search events at a faster rate, almost like a real-time data. So in our use case, we have used OpenSearch at the backend for our extended detection and response product. So this is more around our workload and some of the challenges we had. We almost get billions of events ingested every day. The reason being, almost every enterprise will be dealing with multiple security vendors. Every security vendor will be having critical events. So sometimes we might be dealing with hundreds of products, various products, and then every product is generating hundreds and thousands of events. And as we cater to many thousands of customers across many regions, so we receive like billions of events every day, right? And then there's petabytes of data to search. To make this happen, we had existing Elasticsearch with like thousands of nodes across like many AWS regions and VPCs. So we had a challenge of upgrading these as well as our clusters are in multiple regions, even manageability, operational wise, it's a challenge. I'm not sure how many of you have EC2s running from years, like without shutting down, and suddenly we receive notification that AWS is retiring that instance, so you have to stop and start and then try to move to a new instance, right? So we had those sort of issues, and it's like kind of frequent because we have thousands of nodes to manage. So it's becoming like overwhelming for us. So we were looking for, okay, is there any solution which we could use? So we talked to our AWS account team, and then AWS account team introduced us to OpenSearch. They said, why don't you try Amazon managed OpenSearch service, right? So our first impression was, okay, we are trying to not only optimize our operational challenges, we want to reduce the cost also. So when we are trying to move to kind of managed OpenSearch, then obviously the cost may be more, right? So we wanted to optimize the cost as well as we want to reduce our operational burden, right? This is the use case which we have given it to them. So the product team came back. They said, okay, they tried to study our current workload, how our load is distributed across many VPCs, many regions. So they tried to provide a solution saying that, okay, try OpenSearch in this way. Maybe you can try to reduce replicas, use these sort of instance types, try to purchase savings plan. They suggest multiple options. Okay, so before really trying to do all those things, we wanted to do a POC for that. We thought, okay, so the main factors we have considered, right? From the optimization perspective, if you look at it, OpenSearch charges based on the amount of data which is ingested. We cannot reduce our data because that's the customer data. So we want to know, right? Find a better way. Is there any way to compress data and send it? That was one of the question. And they provided a solution for that. Then we wanted to reduce how much data we can store on the disk, right, in a compressed format. That way we can reduce our EBS cost. Is there any way to reduce replicas as much as possible? And based on our customer access pattern, right, we will be giving different lifecycle policies for different customers based on the contract. So some of them have like 3 days, 5 days, 7 days, 15 days. But if you look at their search patterns, not everybody searches for 15 days of data. Not everyone searches 1 week of data every day, every hour. Most of them search maybe few hours because they are doing some threat hunting. They might want to get some data and then act on it. Maybe 24 hours of data, 48 hours of data, right? They don't try to search for all 15 days of data. Okay, so that is one point for us. That means we need not store or give the data, right, which is being searched by the customer, the high performance nodes. So some of the data can reside on high performance node, some of the data can reside on low performance node, with like not considerable delay to customers when they are trying to do the search. Okay, so that was another use case. So the other suggestion was to use OpenSearch ingestion pipeline, right? Why use OpenSearch ingestion pipeline is because we were using our existing custom indexing option. So we have written code ourselves, we are managing it ourselves. The one challenge which we are seeing with this was almost every month we see the amount of event size, or every year the amount of event size per customer is increasing. That means even though you have designed some ingestion system for today, it might not work for tomorrow. So it has to scale up. It has to auto scale down, so that you can get better COGS optimization. So managing that code, and in some cases, what happens was, as we are receiving events from the customer security devices, sometimes there will be a huge burst of the events, right? Whatever might happen in customer environment, maybe they have saved 1 day of data, for whatever reason, suddenly we see burst of data. So we have to handle spikes. We have to handle almost data increasing every day or every month, right? So we're looking for something scalable, maybe something like robust, which can handle all these things, as well as give us the best cost optimization, right? So we went with OpenSearch ingestion pipeline choice. And the other factor which I talked about was one of the cost from OpenSearch, the costing structure is how much data you ingest. So when we chose OpenSearch ingestion pipeline, in the configuration there is an option to compress your data. So we followed that approach, and it compresses more than 90%. That means even though you are ingesting 1 terabyte, you will be charged at very less because it's already compressed data, right? So that gives us some COGS savings. And during POC, right, we want to do proof of concept. Okay, we assume that, okay, we can reduce the replicas and we can save our cost. Whereas that all did not turn out to be true. And the reason being, with existing instance types, still our data is in EBS, but to recover the data, for whatever reason you went with like no replicas, right? Thinking that we can recover the data from EBS. But that is not instantaneous. It will take, I mean, you still have to go through all the backup process to retrieve your data, which is not like in 5 minutes or 7 minutes. It's like more than 30 minutes, 40 minutes, 1 hour, something like that. So that option is not there. That means still we need to use replicas. We need to have multiple shards for reliability, right? And then we thought we can try to, we re-architected our system such that we created many indexes so that we can search at a faster rate. However, we have hit the limit of number of shards per node. As we have thousands of customers, we are split across multiple nodes, we are creating a lot of shards. So that did not work out. That means we need to retune our sharding strategy. And ingestion pipeline, what happened was we faced a lot of issues with initial ingestion pipeline because the scale at which we are trying to ingest versus the kind of tuning which AWS would have done. So we had to work with backend engineering team. We showed our live use cases. We tried to tune the performance parameters. They tried to fix some of the bugs. Ultimately, it worked out good. And then at the same time, right, we were seeing that we are not getting much cost savings if we are trying to create multiple replicas. So is there any better solution? So around same time last year, AWS introduced OR1 Instances. And I think we are the biggest customer. We adopted it immediately. OpenSearch ingestion pipeline, whatever the changes they did, we implemented. We embraced it immediately, right? And we were doing POC, so we could try to do that. With OR1 instances, as you have seen earlier, at the back end there is an S3. So we try to use that and try to pump a lot of load. The initial issue we have seen was S3 scaling. So they need to tune the S3 parameters, but once those parameters are tuned, backend team tried to optimize the OR1 with the kind of workload we have. It started working like charm, right? And we have seen huge indexing performance improvement, and we need not use entire like a lot of replicas. We went with 1:1 replicas because we still don't want to go make the cluster red in case of any nodes which are lost. And we try to do a DR testing. We try to reboot the nodes and see how much time it takes for the cluster to recover from yellow state. It was around 7 to 10 minutes, which is still okay. So we thought, okay, we'll go with 1:1 replica. Whereas now when I'm talking about that the sharding strategies and all, right, we try to go with the sharding strategy where based on the customers' data which they are searching based on their data, we try to move data to ultra warm like every 6 hours, sometimes one day, sometimes we leave them in the hot node. So we try to make changes to our sharding strategy. And we use our OpenSearch ingestion pipeline with after all the issues are resolved. We have to tune the OCUs. They call them as OCUs, the compute units. So we tune them, and per cluster we have to make changes. In different regions we have to make changes. So we have all the configuration ready. Then things started working good. So this is a simplified architectural diagram. If you look at it, our customer data will be coming to that AWS S3, kind of in JSON format. So the data will be received by OpenSearch ingestion based on that SQS queue. So whenever there is a new data inserted or new batch inserted, OpenSearch ingestion pipeline takes the data and then basically ingests into OpenSearch service, right? So it has 3 blocks. Left side you have the data piece. In the middle, I'm talking about OpenSearch and Amazon so ingestion as well as search service. And on the right side, we have monitoring piece, right? I would like to spend some time here. With respect to OpenSearch ingestion, I have given like one here only. But when we did the optimization, we tried to reduce a cluster per region. We thought we don't want to create like many clusters in every region. However, our past data, right, were having like multiple ingestion pipelines. So the way we tried to solve the problem is pointing multiple OpenSearch ingestion pipelines to one Amazon OpenSearch service. That's why we tried to consolidate the clusters into one, whereas we have many ingestion services. On the OpenSearch ingestion, the configuration was easy, where you will be trying to point it to an OpenSearch service. You will define your compression rate. You will define where the data will be ingested, how many retries you want to do because of some issue if the data is not being ingested, and whatever it is, right? The data could be issue with some data. If the data is not getting ingested, where do you want to save? So we call it as a DLQ bucket, where whatever the data is not being ingested in OpenSearch will be saved in the DLQ. And by the way, right, like it's very easy to create one more ingestion pipeline, point it to the DLQ bucket, and then based on the duration, there are the many options, but you can say that, okay, last 1 day of data, can you re-ingest? It will re-ingest. It's very, very good. That's why we get a lot of flexibility with OpenSearch ingestion pipeline. And similarly, you need not configure a lot of retries, right? Like if you configure, because of some reason, if I'm not able to ingest, don't want to say that, look at 12, 18, 20, because if you are trying to give more retries, it's trying to bombard the cluster. But with re-ingestion option, you can choose less number of retries, because the moment you see the DL cube is increased, you can retry those data at any point of time. And from the cost optimization perspective, right, unfortunately there are no savings plans, there are no reserved instances we can buy, so there is no way we can optimize OpenSearch ingestion. So we pushed the engineering team a lot, saying that we don't want to pay a lot of money because there are no service plans or anything. What is the other option, right? So we really try to tune each and every cluster, and then make AWS make some code changes required, right? So that we have optimal number of OCUs running, which will scale up properly and scale down properly, so that we are not paying a lot of money on the OpenSearch ingestion. So that worked out well. And from the OpenSearch service, again, right, the data, as I mentioned, the costing structure is how much data being ingested, how much EBS storage you are using per hot node, as well as how many ultra-warm nodes you are using, and what is the instance type using for hot nodes, right? So as we try to reduce our cost, the way we did was, as I mentioned earlier, we tried to keep frequently search data into hot nodes, as well as infrequent data into ultra-warm nodes. So, and ultra-warm nodes does not have replicas, they are on kind of low performance nodes. So you can think, right, 1 day of data versus 15 days of data. Earlier search implementation, we have to keep all the data in kind of hot nodes. So we are trying to, we are maybe not enough utilizing those nodes, right? But in this case, you can take the OR1 instances, they are high performing instances, they are doing indexing as well as search at the same time. So you keep all the frequently searched data in hot nodes, infrequent data in ultra-warm nodes, and that's how you can save some money. And with respect to the monitoring piece, right, and how do you react to if there are any issues on OpenSearch, AWS, out of the box, they provided alerts, monitoring in CloudWatch for mostly the system related information, right, like, or the delay in query, delay in ingestion. You can monitor all those performance, they are out of the box. However, for us, we needed per index level, how it is behaving, what is the storage, are there any failures in like rollover from hot to ultra warm. We want to know all those things. Currently, we don't have very detailed information there, so we have to write our own scripts using APIs. So we are pulling all the data from the backend, and we wrote kind of our own script to retry or to do the necessary actions. So I have not provided an API interface, but we are using currently API interface. We have given a feedback to OpenSearch team, so that if they can implement that out of the box, that would be good, instead of managing our own scripts. That is one. Second point was, as I mentioned, we have like many clusters in many regions. We have to go to log into each and every region and then monitor each and every cluster separately. There is no kind of one single dashboard to do all these things. So again, we built our own managed Grafana. We tried to move all these things into one page so that we can monitor that. That also we have to do it. So we asked AWS, can you do something like that so it can be useful for many customers. And migration process, right? Like after all our POC is done, you have seen how do we migrate thousands of customers' data, which is spread across many regions, many VPCs. So we cannot do it in a day or two. So that's why the approach we followed was, why not do a dual write? At the same time, we need to save cost, right? So we picked a region or some of the VPCs in that region. We created OpenSearch cluster. And then at the same time, it's writing to our existing search solution as well as to the OpenSearch. Based on the retention policy required for all the customers, we made sure that, for example, if they are searching for 7 days of data, right? We ran this system in parallel for 7 days, so that 7 days of data is present in OpenSearch as well as 7 days of data present in the existing search. And we stabilized the cluster. We have tuned whatever parameters we can. We made sure that all the lifecycle policies are working fine. And then one fine day, we tried to flip the search from our older search to the OpenSearch. So that's how we were able to migrate many clusters, many VPCs. I mean, it took like some time for us. It was a daunting task for our team. Kudos to our team. So without their help, we wouldn't have been able to do it. At the back end, AWS, we used to inform them. They used to monitor it. They were available for us. Engineering team was ready. If there are any blue-green deployment issues, they used to support us. So we got a lot of support from AWS team too. And then, as I mentioned, we consolidated multiple pipelines into one. That's how we wanted to optimize our cost. We have to implement monitoring across multiple clusters ourselves, as I mentioned. We had to do that. So just to summarize, right, what are the enhancements which we have done? Again, we have split that into index service, as well as earlier we were managing the index policies by ourselves, but now with OpenSearch index state management policy, we can easily configure saying that, okay, I want to keep only 6 hours of data or 6 days of data in hot node. After that, move into ultra warm, and then after 15 days, delete the data in ultra warm. So you can write all this policy. We can write it per index. So based on our customer configuration, we have configured these ISM policies. And there are some failures. If the system is overloaded, that's why we monitor those failures and retry whenever there are some any issues. And then we used OR1 instances. It reduced the cost and then increased the durability. That was one of the good choice for us. And we have built our own monitoring dashboards. Now coming to the fun part, maybe most of you are looking at, right? The COGS saving phase. So we saved close to 35% of the cost, which is like in millions of dollars for us. The main reason we were able to save is because of the ultra warm and warm, as well as we looked at, right, what are the all possible options we have. So in addition to reducing our hardware or whatever indexing strategy we could do, the other piece is trying to buy savings plan or reserved instances. As we know that every year the data is increasing, it is not that we are going to reduce the instances, the instance is going to increase with the number of customers. So we went ahead and bought the reserved instances. That reduced the cost a little bit. And then I hope AWS listens to us and gives us savings plans for even the ingestion pipeline also. We would have saved more, but there are no savings plans for ingestion pipeline as of now. And our indexing performance improved a lot. I mean, we could see how we were doing earlier compared to this with OR1. We could see the performance improved by 40%. This will help us enable us, right? Almost real-time data you are getting the moment ingesting, and it's there available for us them to search. Recently we have not seen any operational issues with respect to indexing, so they reduced a lot. So from the next steps, right, from our point of view, we are trying to see what improvements in query performance can be done on the ultra warm. Right now, if you're trying to search for like 10 days of data in ultra warm, we see some performance degradation. So we are working with the AWS team at the back end. Use generated Gen AI features, maybe vector search, so that we can provide more value to the customers. And use OpenSearch serverless because in some of the dev and QA environments, currently we have set up our hardware, which might not be used 24 hours, right? So maybe why not try OpenSearch serverless, right? That's what we are trying to do. Okay, thank you. Thanks everyone for listening to my speech, and I would like to say a big thanks to my team. Without that, we wouldn't have been doing this, and I wouldn't be here because we were able to migrate a huge number of customers. A big thanks to my team and my leadership team and AWS team to give an opportunity for me to speak in front of you. Thank you. Thanks everyone. And now I'll give it to Kevin to take over.
Thanks, Pawan. Well, that was a pretty interesting use case with Trellix and the cost savings that they were able to introduce to their company. I'm going to talk a little bit more about the provision side of the house. As you know, and Hajar spoke about this a little bit earlier, the OpenSearch serverless is a way that you can get into the OpenSearch service to have search technology, and that does help you from a operational perspective drive those costs down. But many people have larger scale workloads, and some of the limits and some of the features that are offered with serverless are not yet available in the serverless option. So let's look at the provision offering and see how you can optimize your costs here. So for the service offerings we have, typically it's in t-shirt size on top of EC2 instances. And we have a couple different offerings, which are Intel Xeons and also Graviton chips, the Graviton 2s and the Graviton 3s. Now, normally when we look at high volume log analytic workloads, we're usually looking at the R series instances. Now, the R series instances have the R5s, which are the Intel based, and we have the R6 and the R7 GDs and the R6 GDs, and these are collectively the Graviton 2 and Graviton 3 offerings. Now, they're really good for logs and vectors because they do have a larger portion of memory compared to CPU. Now, the I-series instances, if you have super large hot data volume workloads, you can look at using the dense storage on the I-series instances, which are NVMe-based instances, to help you drive your costs down with that storage. Now, on the Intel Xeon side, we actually have the i3s and the i4i, again, NVMe SSDs or instance stores. This is really good for logs, and they also do support vector workloads. On the Graviton side, we have the IM4GN, which are dense storage with a lot of high CPUs, and also the i4Gs, which are EBS-backed volumes. M-series, typically we use these for general purposes. I often find when working with customers that if I have to get more CPU without worrying about scaling my cluster wider from an R-series instance, I could use the M-series. Again, Intel, Graviton 2, and Graviton 3 offerings. Now, if you can do high cardinality aggregations, the C-series instances are really good, and these are typically found for search workloads. There are very few log analytic use cases I've seen over the many years I've worked with the service, but these are really good if you're going to do search. Now, finally, if you just want to get started with the OpenSearch service and the managed side of the house or the provision side of the house, you can use general purpose, low-cost T-series instances, the T2s and T3s, which are offered in our free tier, and they give you the capability to try and work through your APIs and effectively understand how you can use the search features available with the OpenSearch service. Now, if you take a look at the Graviton 3s that were recently introduced with the OpenSearch service, now the Graviton 3s have been out for quite some time. Now, if you're going to move from a Graviton 2 to a Graviton 3, there are some enhancements and some options in here that do help you drive down costs, and they help you actually have better performance. So if I move to a Graviton 2 to a Graviton 3, you could expect basically 50% higher memory bandwidth utilization. So this means that when you're searching things, you have quicker response between the CPU and the operations that are doing your search activities. It also enables you to have up to 25% higher compute performance. And what this means to you is if you upgraded from a Graviton 2 to a Graviton 3, then effectively I'm going to get more CPU, and technically I could scale my cluster in a bit, thereby saving costs and achieving the same CPU performance I would have had with a larger cluster for Graviton 2. Now, we have the M6, the R6, the R6GD, and the C6 series for the Graviton 2s, and there's a comparable 7 series that go with this, with the same instance family and t-shirt sizes that we talked about for the Cs, the Ms, and the Rs. Now, you can achieve up to 20% more enhanced networking bandwidth, and what this means is that communications between these data nodes for your cluster should be a little bit quicker. And so you may, over time, depending on your workload, see some improvements even with the networking capabilities. Now, another option we have out there is the Intel Xeon Scalable. For many, many years, we've been running the 5 series instances on the Intel Broadwells, and there's various flavors of this between the i3 instances, the Cs, and the M5s and the R5 series. But in the end, if you look at the Intel Xeons for scalables, you could expect to see a 30% better price performance with moving to that instance family. And the cost to do so are very, very small and minute, but the performance gains that you'll see from these are significant in many cases depending on how you test. Now, you can see up to 60% lower storage latency, which means the instances as they're communicating with the back-end storage, typically GP3 volumes, will be a lot quicker. So data I/O transfer or rates coming back and forth between your CPU and the memory and also the disk can improve significantly, which means that your workloads will be faster and technically your response times will be better. Now, if we look at the i3 instances compared to the i4i, which are the Xeon scalables, you could see up to 75 gigabits per second as far as network throughput on the highest instances that are out there, the largest instances that we have. And so consider these when you're looking at maybe modernizing your fleet to get those cost savings and better performance. Now, a lot of times I speak with customers and we go in and it's all about costs, and we'll tune the cluster, we'll work on sharding strategy, we'll do everything in the bag of tricks to bring the cost down, and they're running on demand. Now, I like to talk about reserved instances because many people feel like it doesn't give you the capability to move between instance families when you enter into a reserved instance agreement. Now, normally I'll look at a 1-year reserved instance so I can change those things if I have those concerns. But if we look at it, no upfronts are our most popular. You don't have to put any money up front. You pay for a discounted hourly rate, and in many cases, as you're looking across these workloads, you're going to get up to 31% savings for a 1-year no upfront RI, and for a 3-year you'll get 48% savings, which is significant when you're looking at the long-term value that you can get with the Amazon OpenSearch service for your particular use cases. Now, partial upfront means that you're going to pay some cash upfront, and you're also going to pay an hourly rate. Now, that portion of the cost is paid up front, and that discounted hourly rate will enable you to achieve 33% savings on a 1-year no upfront, or 1-year partial upfront, and for a 3-year partial upfront, you have roughly a 50% savings on your on-demand costs. Finally, the all upfront is where you commit all of your money up front. Many people that have financial organizations, you're looking at a budget, people want to plan for that year and put the money in and not have to worry about it for the remainder of the term. In this case, we offer a 1-year, which gives you up to 35% savings, and a 3-year, which can give you 50% savings over on demand. Now, some of the things that I do when I'm working with customers and tuning clusters is we talk about pro moves. Now, a buddy I used to work with at AWS who's since left, we always talked about ways that we could do things that were really unique and interesting. Now, one thing you can do is if you have i3 instances, you can upgrade to IM4GNs. IM4GNs basically have double the density of the storage, which means you need less instances to achieve your mission. So let's take an example use case. 2 terabytes raw data ingest per day. 90-day hot retention. This is no ultra warm or anything else. And you're across 3 availability zones. Now, doing some calculations, which you can work myself with Hodger or any other specialist SA, we will help you get a nice cost profile. But in this case, the numbers come up, if you're having a consistent workload on demand, the numbers will come up with roughly 45 i3 instances, which each have about 3,800 gig of storage per, and that monthly on-demand cost for a cluster of this size is roughly $67K. Now, this is just on demand. Now, if I procured, or you procured, if you were running this workload, 1-year no upfront, it's a NURI, you're going to only pay $46,000 roughly per month. Now, if you decide then, well, let me try Kevin's cost optimization trick and let me go for the IM4GNs. For the same volume of storage as Pawan mentioned here, your costs are basically in the storage of the data at rest. You usually get a lot of CPUs with log analytic workloads. But in the end, if I went just that move for monthly on demand, it will only be $38,000. But with the no upfront RI, roughly $27,000 per month. Now, this is basically 42% cost savings of what you currently have. So for those of you that are enterprise customers, even smaller segment, reach out to your service SAs, get in contact with us and we can help you out with some of these activities. Now, let's talk a bit about storage tiering. As was mentioned earlier, we have a bunch of different options in here. Technically, you have the hot tier between your Intel and Graviton chips, fastest access, cost is linear. As you add more data, the costs go up. And it offers all the features for OpenSearch. Now, when you start looking at the hybrid instances, such as the OR1s backed by S3, or Serverless, which is backed by Amazon S3, UltraWarm, which is backed by Amazon S3, and our recently introduced Zero ETL feature, which is direct query over Amazon S3, can give you significantly less costs when you store that data in the S3 tier. Now, there is some more latency associated with it, but it gives you the ability to have increased durability on your data and your workloads. And using zero ETL means that the data can always sit on S3, and only when you need it during query do you have to bring it back in. Finally, we have cold storage options. Zero ETL does fall into this path, and we'll talk a little bit more about zero ETL in a second. But with cold storage, the data will sit on S3 at roughly S3 costs, and only when you need it, you can bring it back in. So think about archival activities, 3-year, 7-year compliance needs, and zero ETL and cold storage are great for these particular use cases when coupled with your warm and your hot tiers. Now, Direct Query was recently released here, probably about, I'd say 4 or 5 months ago. What's nice about it is you have a pathway to query data that's sitting on S3 now. You can do interactive analytics on the data on S3, query the data where it rests. You don't have to bring all of your data into the cluster. And we use serverless compute behind the scenes, which is a Spark engine, to query across that data. And then in some cases, you can actually boost the performance of the offering that you have here by leveraging things such as skipping indexes, which we'll talk about, and also other constructs such as materialized views, which only bring the result sets back in, and you can visualize those. Now, the way it works is that, with the Amazon OpenSearch service, all your hot data goes into a hot tier, typically primarily your application logs and things that you want to get quick responses on. Now, for things like VPC flow logs, WAF logs, and other logs that are interesting for discovery but maybe cost a lot of money to bring into OpenSearch in high volume, consider using S3 and zero ETL to query across this data, because you can have dashboards and visualizations on top of the data, and you don't have to bring all of it in to query it. And it provides a nice blend and mix between a hot and data that's in a warm or cold tier. Now, skipping indexes will enable you to say, for a particular query, ignore this data because I already know it doesn't have anything inside, so why don't I just go ahead and skip over the object on S3. Materialized views are just aggregations that we bring in, and typically you're taking hundreds of thousands, if not millions of documents and condensing them into basically one row, or one document itself as far as an aggregation. Now, covering indexes are just write a query, bring the result sets back in from S3. But all these enable you to tap into that cold storage tier. So if we look at some of the efficient cost optimization patterns, and these are ones that I work with customers on, and you can see that Pawan, with his company, leverages one of them, and that happens to actually be Amazon S3 events with OpenSearch ingestion. Services write to S3, particular agents like FluentBit or your OpenTelemetry agents can also write to S3, and by using the bucket notification patterns with S3 talking to SQS, we can index that data using OpenSearch ingestion with a really quick and simple blueprint. Very, very simple setup. Get your IAM roles in place and you can start bringing that data in, and now you have this nice cost-effective pattern where all of your logs sit on S3, you address your compliance needs, and you only bring what you need into the Amazon OpenSearch service. Now, so we'll read that notification, crack open the object, and index it into OpenSearch. Now, one of the emerging low-cost patterns are to leverage OR1, zero ETL, and OpenSearch ingestion. So what does this look like? Agents and services can write either to S3 or to OpenSearch ingestion. You can actually use OpenSearch ingestion to write data that comes in whatever format to Parquet on S3. And this is great if you have bigger data lakes and other things that you want to query, or you can use direct query with Amazon S3 for the zero ETL and query that data on S3. Parquet is really efficient, compressed, and cost optimized. Now then what happens is bring it to OR1. You don't necessarily need replicas on anything after the data that's currently being ingested, the hot indexes. And so you can save a lot of money there. And then you can query that data that's sitting on S3 for the long tail data or the compliance needs. Finally, you query through Amazon OpenSearch dashboards, both the cold and the stuff that's sitting on S3 and the hot data and the warm data that you might have brought in. And you can visualize that data. So I just want to go ahead and wrap things up. For getting the most out of your OpenSearch workload, just a couple key points I want to point out here. First of all, if you have the appetite for serverless and it works for your particular workload, you can use it to decrease your operational burden. And your team doesn't have to learn how to actually build or understand a search engine. The next thing, leverage OR1 and UltraWarm. That gives you the capability to then bring that data in and have a way that you can have it backed on S3 and then query it. And unfortunately, our time has run out, but I'll talk through the rest of the things. Zero ETL with Amazon S3 is another cost-saving mechanism that you can use. Go ahead and use reserved instances where possible. And on top of that, I just want to thank everybody for coming out. We do have another cost optimization talk tomorrow between 11 and 12:30. It's going to be at one of our other venues. I'm trying to remember this from memory, but I'm not sure where it's all going to be. But in the end, thank you for coming out here. Appreciate your time. Sorry about the hiccups in the middle here with the gear. But have a wonderful rest of your time at reInvent. And if you have any questions, find myself, Hajar, Pavan in the back. Really appreciate your time. Thank you for coming out. And it's been a pleasure talking to everybody. Thank you.